Okay, I'm Lucas Pardue. You saw me earlier, maybe. I'm an engineer at Cloudflare, and I work on HTTP3 and QUIC. I'm not going to make that same joke I did earlier. My background is I used to work at the BBC doing video streaming stuff. These days, I just work on protocols. So we're responsible, the team I work in, for the first eyeball connection into Cloudflare. So things like TLS, QUIC, HTTP2, HTTP3, all of these things. So, stop. Celebrate, but don't listen. The IETF has a new invention. QUIC, it's better, maybe, but it's available now in Chrome Canary with flags. Packet drops affect flow. Watching acts will let you know. Streams rock and nick like a vandal. Packet delays wax like a candle. So relax, I'll be done soon, teaching QUIC with 90s rap tunes. I'm happy when we use cryptography. Anything less than the best is a felony. And we have open source code, enable it to play. You better get on GitHub and check it out today. And if you have a problem, you will solve it. Open an issue, and I'll quickly resolve it. Thank you. So IETF QUIC, this is not Google's QUIC. This is the IETF standards world, which I live in. I contribute to the working group activities, and mainly HTTP3. But this talk is not going to touch on HTTP3 much, because I'm interested in the future of what QUIC could enable for people, reinventing or creating new opportunities. See what you think, and then talk to me at the end, because I'm really interested to find out what other people think. I've been in this world too much. I'm still really excited about it. I know other people are a bit worried or dubious or whatever, so I'm really looking forward to having a chat. But what is QUIC? This is a transport protocol that's secure, reliable, and mitigates head-of-line blocking. And what we're going to do is a massive deep dive into packet format. No, we're not going to do that. That's my final 90s reference, not. There's so many good resources out there already on QUIC. It's not a new thing. It's been going since 2012, right? But the problem is there's a lot of stale information out there, and that's the danger. You read a new blog post that maybe hits high up on Hacker News, and it's partially true and partially false, and that sucks. So we're trying to educate people and improve the situation, but it's difficult because those specs are still evolving and things do change. But I definitely encourage you to have a look for stuff. Daniel Stenberg's talk on this is really good, and he's a nice guy. So instead, what I want to do is challenge some myths about QUIC that sometimes I hear in passing when I speak to people who don't spend 8 hours a day reading emails and Slack channels on QUIC. And the first one is, it's an acronym for Quick UDP Internet Connections, and that's just not true anymore. This was removed like 2 years ago. So when you say that to me, I die a little bit inside. It was fine. It was an acronym. It was never an acronym, but it's not anymore. So just please, if you're going to say it, just shout it. Don't try and expand it. Myth 2, it's owned by Google. It was made by them, it was their baby, but the whole way IETF works is if there's value in a protocol like this, we want to standardize it for better interoperability. And the IETF has a long process to even consider adopting that work and what those things might be. And the first time around, it was bounced, I think maybe a year later, in Berlin a couple of years ago. It was adopted, and a working group was formed, and those working group people involved many stakeholders, many different companies, from CDNs to browsers to middle box vendors, all of these kinds of people. And so during the last 3 years of development, what we have is over 16 implementations who are working actively on QUIC. A lot of them are tracking the specs as they change week in, week out. There's a great page there that lists them. They come in various languages. Some are open source, like mine, or my team's, and some are just like a box you can buy. So it's cool, and I'll come on to a little bit of that later. Myth 3, it's just a glossed version of the original QUIC. That, we take something that's been proven to work at web scale with loads of great presentations by Google, with real data, which is amazing, and that we're just going to fix some things and make it better and rubber stamp it and ship it out. But that's not true. There's many breaking changes. The biggest one to start with was changing the endianness of the wire protocol. That really annoyed some people, but made others really happy. And we got that dubious, no, contentious problem solved very quickly. And now we're all on the right endianness. But to kind of disambiguate the two, we commonly use this term QUIC to refer to the Google version, which is still in active deployment in some cases. So when someone says, I can talk quick with Chrome to my browser, you can, but it might be the older version. It might be QUIC. If you use Chrome Canary with those flags and you talk to the correct server, you might be able to talk to using IETF QUIC. And the final myth I have today is that IETF QUIC is a burrito, which is a pretty bad analogy. So what I would mean by this, and it will be what I'll spend some time talking about next, is that Google QUIC kind of rolled in many of HB2's features into its design. Realistically, it's BD, not H2, but today it's H2. And it did this to get better performance, or whatever you want to describe it as. But to me, this, although it worked, I, in my previous life, helped design and build a proof of concept that was using Google QUIC to do something it wasn't intended to. And it was really hard to pick out the pieces that we didn't want and to customize things and extend it in certain ways. And that's a barrier to actually demoing new use cases or new concepts and getting other people to buy in to this thing. And that's my perspective. So, the analogy, speaking to some people internally, is that, it's like a burrito that's already made. If you like it, it's great, but you can't pick out that guacamole. You're better off looking at IETF like a tortilla. And on the theme of food, this is like a layered cake diagram, just so we're all clear on the layering of QUIC and where it fits in. It's a new transport protocol, but it sits on top of UDP. And working from bottom up, you have QUIC packets that have some properties. I don't want to describe them because it's boring, but you had this speedy syntax. So this is the way that you would take at the top a HTTP request, a logical entity, and convert this into the wire format, say like headers frames and data frames, and send them on a stream or whatever. But the layering wasn't actually like this. It was more like taking those layers, reforming them, and then just smashing it on top of UDP. And unless you cared about this, you wouldn't know, but I do care, and it deeply upset me. And so now we have a better layering. The IETF process identified the value in the transport protocol and that it had other use cases that maybe weren't so specifically tied to things like streams or web requests, and that by having a cleaner layering, albeit very similar for the main use case, which is what we're trying to deliver as an MVP, actually what you could do is cut the top off and chuck it in the bin, right? And this pains me so much because I spend all my time working on those upper two layers, and yet I'm stood here advocating for doing this. And it kind of works well. And what it lets you do is then layer stuff on top of QUIC. So in this example on the left side, I've got QUIC within, UDP, QUIC within UDP, QUIC, layering and layering. Or maybe you just want to do UDP in QUIC without extra layers upon layers of QUIC. And you can ask, like, what is this about? Like, where's the application layer? And that's for maybe you to put on the top, the cherry or the strawberry or whatever. And so I'm not alone in thinking this. It's not new, right? People have been layering and doing IP tunneling for years and decades. So what we have, this link at the bottom, is a link to a IETF draft, which is, say, let's collect some use cases. It's call it QUIC as a substrate. And the example I would use, the one I feel most strongly around, is just basic HTTP connect level tunneling that you might use in a forward proxy. Right now, the way things work, you can't do that. And some people might want to. It's got some value, even if I'm the only person who thinks it's that use case. So I would maybe ask you to look at this document and see if your use cases are there. I don't know. It's a bit maybe impossible, so if you think you might have something, come and have a chat to me. But to give you some examples, you could do DNS over QUIC, right? That could work. you could do IoT stuff over QUIC. Take whatever application layer protocol you want to do. You have the security, the reliability, the head-of-line blocking mitigations that QUIC can provide. Whether you need all of that, I don't know. But what we care about is doing kind of like video streaming stuff. We've had some really great talks over the last 2 days touching on different approaches to these things, different problems, whether that be for distribution, which is what most people think QUIC's about, or whether it's contribution in. And like, I don't have the answers here because I don't work across everything. But I know some of the properties of QUIC could be desirable to some of the kinds of workloads that people do. So if you're going to try and do this, like I gave you the links to the repo, and maybe you did check it out and try and build it. Or maybe you just got an ice cream. I don't know. But like, it's a really tough question. I've mitigated the best question, possibly, whoever just asked that already. You know, the reason that I would say you should try and pick QUIC over other things that we might have seen today, it has quite a sane security story. No, we're using just a normal TLS handshake and the web PKI. We're not using QUIC's QUIC crypto handshake, which was more of a proprietary way of achieving the same goal of establishing a shared key and then encrypting the packets, which raises some issues. You know, was it FIP signed off, and could that version of QUIC be used for certain kinds of use cases and applications that would sit on them? We don't need that worry anymore. We're just using a TLS 1.3 handshake, and you can assert identity or authentication just using something we're familiar with. It fits into the web model, but I know that doesn't suit everyone's needs. It's also a sane stack, to me at least. Like, I look at something like WebRTC, and it just, I can grok it, but then I couldn't find any way to build a simple proof of concept for this thing. So it's layering things like SCTP into UDP or whatever. I can't even remember. I looked at this diagram years ago, and I wanted to avoid confusing and upsetting everyone by showing it. But it's also an IETF adopted standard. I love the IETF. It's great. It's not perfect, but it's an open thing. So, you know, the specs have been open from day one. As soon as they were adopted from the IETF, the way that they're produced and made available, the way people contribute via GitHub issues and pull requests is open. It can be a bit obtuse to understand how to contribute or read stuff, but that's the way I like to work, in the open and showing things where possible. What else is good? It's had production experience of operating at web scale in some shape or form, and you know, today we have enabled HB3 and QUIC on Cloudflare's edge, and we're trying to understand how it behaves for like the real world, real traffic flows. And there's also loads of implementations, like I already mentioned. So what we have here, which is awfully rendered, is what's called the QUIC interop matrix. So last week, I sat with, say, 30 other engineers, and we did a 2-day interop event, which happens at every QUIC interim, where across in the columns represents a server implementation, and the rows represent clients. So I don't want to dig into this too much, but more green, more color is better. And what each of these letters represent are some feature of the transport. So for example, a V means version negotiation, or in this case, a 3 means HTTP 3. And you can see there's like loads of different things going on, and it's kind of cool. So to me, what this demonstrates is that there's a lot of people actually working on this thing who come from very diverse organizations, or maybe it's just an open source student project, and that these things are working. We're not completely there yet, but not all of these features are mandatory anyway. You need to pick which ones might suit your use case, your business case, etc. So what I want to focus on now is something called QUIC streams. So what are they? These are the first class transport primitive. It's basically taking something like H2 streams and pulling them into the transport layer. And what that lets you do is have a flow control window for a connection and a stream without having two flow control windows for the connection and the stream at separate layers of the stack, which is just confusing for a lot of people. And what they give you is reliable delivery, right? the transport layer fixes any gaps, any losses that might happen. How it does that is extensible. It's great because you can use different loss recovery or different congestion control. The specs recommend a really basic way of doing it, but there's space to innovate. Yeah, you can do it with TCP too, right? We have loads of experience. Those are good papers on stuff, but the ability to do that is hard because it requires kernel changes most of the time. Whereas because QUIC is based on top of UDP, the sales pitch is that you can do everything in user space. Doesn't mean you couldn't do it in the kernel too. And there are some people who are looking at optimizations in that space. So a stream singularly has reliable in-order delivery, but across streams, they're independent. This is a whole head-of-line blocking fix. You can basically send concurrent resources or concurrent bytes on different streams, and if some get lost in the network, we haven't got this TCP header-line blocking stuff. I don't need to say more. There's much better explanations and resources on that. So how do you use these things? It's just continuous stream data that you would send onto a stream, and the transport would handle chunking of that data and sending it in a stream frame. So a stream frame just has an ID to say, this is a logical flow. It's up to the application mapping to describe what those stream IDs mean. I'll explain that on the next slide or two. But the multiplexing aspect comes into how you decide to pack QUIC packets. You could send no stream frames in a packet because you're sending ACKs or other data. You're doing a handshake. There's no established safe session yet, so you wouldn't send a stream frame in that case. And packets are sized to MTU values. So the stream gives you the ability to send arbitrary length data independent of IP concerns, of MTU or fragmentation and stuff. But again, that doesn't suit everyone's needs. And it's a departure from if you're familiar with TCP and TLS, with TLS records. Those can be bigger than can MSS or just IP packet size. So what QUIC has is an idea of stream types. So each stream has an ID and an initiator, and that effectively combination can determine a type. So we take a 2 to the 62 minus 1 ID space and use a bit mask, and we have these different types. Client initiated bidirectional. What does that mean? That means a request. A client would open a stream, send a request, and the server could respond on it. That stream is bidirectional, and therefore you can just use the stream ID to coordinate that this is the right response for the request I made. Server-initiated bidirectional in HTTP3 is completely undefined. It's a complete waste of that quarter of the available space because the models we have for HTTP3 don't really support that mode of delivery. But we have something new. We have these unidirectional streams, and what they're used for is to allow things like server push. So you would make a request and get a push promise on that bidirectional stream with an ID for a push, and then the push would just arrive on a new stream. And this supports certain modes of interaction much better. So for instance, the way that the HTTP3 handshake works is to both sides just open a unidirectional stream and send settings at each other. You can optimize around certain conditions and not wait for the other side to send you things, if that makes sense and you're able to manage it. So this is great for things like quicker handshakes. So yeah, I've already touched on this because I couldn't see the slides because of problems. But yeah, if you are thinking about streams, like as an application, you need to be able to map to what the QUIC transport provides you. So you need to consider what your data flows are like, and interoperability with people. What I mean by that is creating a spec somewhere that says server-initiated bidirectional streams mean blah, and someone can go write an implementation for that. So you can just be a server and they can be a client. It would really help just to document those things. In a mapping specification. So I talked about these things. We've got request IDs. If anyone's familiar with HTTP2, stream ID 0 was special. It was a control stream. You reserved one stream in that entire bidirectional space for control but that's gone. They're unidirectional streams. So we can start at 0, which everyone likes doing, and then you would make subsequent requests by incrementing by 4. So you got 4 and 8. And these other unidirectional streams can be multi-purpose. You can create extensions into HTTP by sending a unidirectional stream with 1 octet at the front and defining a subtype. And at the moment, some people are doing that. It's kind of cool. But it's all within the same application mapping context. So this is extensions to HTTP3, not taking QUIC and saying, I'm a new application protocol in my own right. You're basically smuggling different things into HTTP3, which is fine, but requires maybe a framework for negotiating extensions. So they change core assumptions that a web browser might make about how the streams are being used. Probably. Is that okay? Probably. It's just something to be aware of. But guess what? Not everything needs streams. Like, we're doing video streaming, and it sucks because I don't want reliability. It can break things. So, if you don't want ordering or reliability, you're stuck as it stands today. Then the charter for the QUIC protocol mentions the ability to do partial reliability, say. But it says you should enable yourself to allow that to be defined. It just doesn't define it. So why pick QUIC? What did I just tell you? No, we've got to say an extensibility story. It's not perfect, right? And we need those extensions to be made. Well, I think it's pretty strong. When I look at other transport protocols, I look at my experience with them in the past. So one of these, I'm just going to go through some. It's called the Datagram frame. And this allows unreliable delivery of messages. So this is a spec that's being discussed in the working groups and in the IETF, and is seeking adoption somewhere to be, let's do some experimentation, see if this thing's useful. And it's a frame with an optional length. And that's it. You can shove whatever you want in there. The only criteria is that the datagram frame doesn't try and span a QUIC packet. So if you can fit small messages within a datagram frame, you're probably golden. But if you need to be able to span multiple packets, that's probably where you need to create an application mapping to, say, coordinate or tie those packets together. And again, I don't think any of this is new, but there might be application mappings that already work on normal UDP, and you could quickly translate them into QUIC. And the benefit of that is that you get the handshake, you get the web API, you get connection, effectively different flows and different mixing and matching, all within the same connection. And all of the assurances of, say, if you wanted to mix datagram frame with HTTP3, like, you can do that as long as you negotiate the extension up front, and that lets you benefit from all of the cool HTTP3 stuff, like connection coalescing or server push. You can basically split up your protocol into something that has a shared fate. We don't want to be able to... we don't want to have to use different connections and try and coordinate across connections because it's difficult. And so last week, I spent some time trying to put this into practice. It was the quiche library able to be modified in such a way to add this frame that is effectively just an integer and then a bunch of bytes. So I've got some really, really rough work in progress code. I'd love to speak to some people and see if we can come up with just a client and server application that is of interest. Right now, that code just sends hello from the client and the server prints it. We could create an echo server or something like that just to demonstrate these core principles. And then we have something called web transport, which is basically being built on top of Datagram. This is stolen directly from the overview in the document. So this is something coming out of Google, and they're going to be looking at running what is called a birds of a feather session at the next IETF. What this means is there anyone in the community who maybe thinks that this idea is of interest and is worth enough to create more meetings in the future, or maybe form a working group to try and standardize this work? So what is it? It complements WebSockets, gives web apps access to better performing net comms, provides a mechanism for reliable and unreliable bidirectional client-server transmission, it provides security guarantees and fits into the web security model. And there's going to be an API. Anyone else who's ever heard me moan about server push? will know that not having a web API really sucks to try and do cool new things. So that's going to happen in W3C, according to the plan. And then the protocols aspect will be in the IETF. And what Web Transport will let you do is basically have something very similar to WebRTC data channels, but without WebRTC. And I think that's a net win, personally. But it's really early days. And some of this relies on Datagram. So personally, for me, by having Datagram as a foundational component, maybe in the future I want to look at this, or maybe not. I don't know. But I'm excited. And there's other cakes in the oven. There's other people out there in the world looking at extending QUIC in different ways. There's a proposal here for RTP over QUIC. The question here is that better than Datagram alone? I'm not a proponent of the draft. I did RTP work about 15 years ago. I can't remember much of it, but to paraphrase my understanding of it, is that it would basically incorporate more aspects of real-time delivery into a standardized extension, so not everyone is recreating and wasting their effort to define timings and exchanging properties, etc. And that's a draft. I think that link takes you to it, so maybe check it out. How that is going to net out versus Datagram, I don't know. So it's going to be really interesting to see this work. Partial reliability I mentioned. So this is an ability to use streams, not Datagram, say, but you can have selective retransmission of stream data. There's a proposal that I've linked to there. I know other people in the community are also looking at this to enable different kinds of video delivery. So it's really exciting on what's going to happen here. There's also multipath. You might be familiar with multipath TCP, which has been going on successfully for a long time. And this is like one of those stale information. It's been touted as a massive feature of QUIC, and all you need to do is enable it, and then you can walk from your house and do these things. But there's no definition of it right now. There's undoubtedly people researching this and publishing some documents based on their experience with multipath TCP. But it's not defined yet. But it doesn't mean you couldn't, if you're that interested, join the party and get involved. And then there's something I was working on for a long time, which is multicast of HTTP3 and QUIC. So this is based on a premise that scalable video delivery is hard. Let's use multicast. Yay, multicast. But really, there's loads of protocols that you can use with multicast. So why would we try and do it this way? The benefit in this case was that you could send HTTP metadata along with the resources in band. It fitted the workflows that we're familiar with, where we're pushing content using post, for instance, or we're trying to program in Node. And the HTTP semantic is such a strong one. I don't want to have to recreate metadata in XML files and send them as side-loaded things in places. It just sucks. But it's a thing. It's a draft. There's a proof of concept code, and that's all it was. So we'll see if people are really interested, come and have a chat. Maybe we can breathe some new life and new interest and drive it through into the IETF. I don't know. And then finally, there's something called NQUIC, which was an example of replacing the TLS key exchange with something else that's maybe more familiar with, say, pre-shared keys or constrained environments, constrained devices that have difficulty doing stuff. So the talk was called Reinventing UDP Streaming with QUIC, and to try to summarize my thinking during this talk, I list the benefits of QUIC. It's secure, it's reliable, it's a transport, and it's interoperable. And then I look around the room, and we've got SRT, which is secure and reliable, and it's a transport, and RIST, which is a reliable, interoperable, secure transport. So I think there's a sense of reinventing just outright going on, which is not strange in the technology worlds, but I don't know enough about the other things to understand what's unique and has a USP about SRT or RIST versus QUIC. All I know enough about is QUIC and why I think it's the future. And I don't want to cast shade on these other things because they might well suit their role much better than QUIC could right now, wouldn't get there for a number of years. It's just something to consider. So tell me what you think. You can like, share, and subscribe to my channel on Twitter, and I'm done. Thank you.